All right, Terraform init everyone. My name is Timur, and today you're going to hear a Terraform story. And the narration of this story is built quasi-chronologically. There are going to be days from starting day one when an organization starts using Terraform, and ending up with day 8 with all the bells and whistles implemented. Everything is super advanced and fancy. And one thing you should know is that a day in this presentation is not a real world day. It's just it could be a couple of months in the real world, or even a year or more. The idea is just the structure. Now, I actually want to bring your attention to to this thing. This is not a random picture. It's a Westminster Bridge Road built in London in 2015. It's I think it's a college, dormitory, and I think offices. And believe it or not, to me, this is Terraform. Who thinks the same, and why? Okay, that's fine. So, to me, this is Terraform because it's built with fashionable materials like glass and steel, which is like Golang and Terraform. It's super fancy. It looks robust. It's modern, and it provides a living space and studying space for students, such as what Terraform does to our developers. It provides an infrastructure for them to run their software. And it also reminds me about Terraform because it looks great, it is functional, but also it's really hard to build, or in this case to construct, and to maintain. Just imagine, these steel panels have to follow the curvature of the building. Each of them is different, and manufacturing those panels is probably not fun. And when the building is built, it has been built, how do you, let's say, keep it clean? In a normal situation, if you want to clean the windows, you'll probably have like a movable platform hanging from the rooftop, moving around and cleaning all of those windows. But what do you do in this case when you have a vertical curvature, horizontal curvature? Oh my God, what has happened right now? Okay, hold on. Oh, it's a screensaver. That's too bad. I'm very sorry for that. I guess I need to... No, it's okay. I will turn on this thing. Where's this thing? 1 second, please. Yeah. Set for 1 hour. All right. Are we back? Yeah. Where was I? Yeah. Cleaning those windows is probably a hell. So is maintaining Terraform code over time. And yeah, this is a Terraform story. One disclaimer. As you could see here, I use Terraform and OpenTofu. In the context of this presentation, the difference between the two does not really matter, because they still have mostly overlapping code base, and the features are also very similar. And whenever I will say OpenTofu or Terraform, you can think that it's either or. Doesn't matter in this case. All right, let's start. First day, your company has just started using cloud, for example, or you're on the cloud already, but managing your infrastructure else how but Terraform. It could be ClickOps in the UI. It could be some weird Python library to do that, some SDKs, whatnot, bash scripts. You manage your infrastructure, but you don't do that in Terraform. And then everybody tells you, wow, Terraform is so great, everybody's using it, it's so easy to use, the HCL, everything is super, just do that. And you're like, okay, let's do that. You go into the documentation of the, let's say, AWS provider, and there's an example. There's like EC2 instance code snippet. You just copy it, paste it, and maybe you adjusted a couple of things like instance size or something like this, and you run Terraform plan, you run Terraform apply, boom, you have your instance up and running. That was really easy and was really exciting. So you decide, well, I'm going to use it. It's a great tool. I love it. The problem is that, of course, is that if you already have infrastructure running in your AWS account, now you have to somehow start manage those resources with Terraform as well. So let's say if you have 25 instances running already before you start using Terraform, you now have to bring them under the Terraform management. And Terraform does that in a way of having a state file where, which makes it aware of the real infrastructure. And you'll have to bring your real resources into your state file. That means let's say there are two ways for that. One is there's a new or relatively new import block that you need to put in the code, or there's an import command in the CLI. In both cases, you'll have to first know the exact ID of the resource. Second, match it with the address in your Terraform code. Resource by resource. This is a manual task. This is a very boring task. And you just accept it. It's one time. You just start using it. It's going to be great. I will do that. And you do this. Now everything is great. And then the day two happens. You are really excited about all this Terraform. You figure out how to manage multiple instances under one resource with count or for loop blocks. You discover the power of data sources and implicit dependencies. It's when you can cross-reference the resources. You discover that you can also deploy your RDS instances, S3 buckets. You deploy a whole bunch of AWS infrastructure with Terraform. And then you kind of notice that your code gets messy. You just have one file with everything, and it's like, no, that's not going to work out. You look up for best practices, and there you see that people recommend splitting everything by files, where you probably might have like databases.tf and network.tf or whatnot. There's like multiple ways of doing that. You do that. Maybe that's not enough, and then you start splitting things by directories, hence coming up with your first local Terraform module. It's a great way of reusing code. But the thing is that as soon as you do that, your existing infrastructure is now not in sync with the state. And now you need to resynchronize it, because the address of resources has changed. It now has a prefix of the module name. What do? There's a move block. There's a move CLI command. You could also touch Terraform state JSON. Don't do that. Again, one-time task, very manual, very annoying. But you do just that, and you move forward. On day 3, you realize that you don't really want to test your changes on production environments. So you decide that you want to do multiple environments. You're going to bring sandbox or dev, maybe staging or whatnot, code, whatever. And how do you do that? You just put everything into one bigger module and deploy it multiple times with either count or for loop, depending on your situation. And then, once again, you have to do the state manipulation, because you, again, moved everything to a new module. That's OK. You're already used to it, right? You probably already even developed some sort of a helper script to do it faster, to semi-automate your state manipulations. That's OK. But you've done that. You run Terraform plan. And you wait. You wait. And 5 minutes later, you get a plan. And you're like, oh, that's not good. It takes too long. Because if there's an error, you just wasted 5 minutes for nothing. So what do? You got to split that. There are a couple of ways. One of them is using Terraform workspaces. It's not really popular these days. Don't confuse it with Terraform Cloud workspaces. But it's a way to manage, let's say, similar environments in the same state file, but or substate, doesn't matter. Or you could just actually split your environments and have a stack per environment or a state file per environment, which is probably the way to go. And then once again, you need to move your resources. Having done that, you're still excited about Terraform. You discover that you can not only manage your AWS infrastructure, but actually do that for pretty much anything that has public API. You could do that for your Datadog monitors, for your Grafana dashboards, for your, I don't know, Akamai infrastructure, pretty much everything. You could manage identities in Okta, you could do everything. So you start doing that, right? You bring up all of those providers, you manage your vault secrets, you do all of that in Terraform. You have 5, 10, 15 third-party providers. And then you realize that each of those providers has their own release cycle, and that you have to kind of follow the changes, and that you might have a new version of each of them every week or two, sometimes with a breaking change, and it will consume a lot of your time. So what do? You know, there's things like RenovateBot. It can manage updates for you. It will create pull requests every time there's a new version of your provider. The problem is that obviously it just creates pull requests. You still need to test it. You still need to manually review what's happening there. And if there is a bigger change, let's say they're, I don't know, changing the way something is created, and this will maybe even destroy some of your infrastructure. Manually reviewing all of that, manually testing all of that every week will consume a lot of your time. And this is extremely painful. But you still are probably enthusiastic about Terraform, because you got such a powerful thing. You can manage everything you have in code. Yeah, with a small drawback, but okay. After a while, your team grows. You have more and more DevOps engineers, SRE platform developers, whatnot. Everyone is working with your Terraform, and obviously you have a problem of works on my machine. Someone runs Terraform on Linux, someone on macOS, and then Windows guys are like, oh, it doesn't work for me, the passes are not, whatnot. And of course, the answer to that is to start using a CI/CD pipeline. It will also give you a more streamlined development and deployment process. So it's always a way to go. And the best thing, of course, that you already have very likely a CI/CD provider that you use for your software, for services. It could be GitHub Actions, it could be Circle CI, GitLab CI, anything. And you could just do that for Terraform too. The problem is that the way Terraform is developed and deployed is kind of specific and unique. You have to be aware of the plans. You have to be aware of sanitization of outputs to not accidentally leak your secrets to the pipeline or whatnot. And you got to do that workflow really good. And you can do that, definitely. You can spend a lot of time tweaking your GitHub Action workflow to make it really perfect for Terraform. But believe me, it will never be perfect for Terraform. Fortunately, there are third-party solutions, so-called tacos, Terraform automation collaboration software, something like this, such as, Spacelift, Terraform Cloud, env0, Atlantis. There are plenty of them, right? They are tailored for Terraform or OpenTofu. We actually moved away from our custom actions to Spacelift a while ago, never looking back, because it's just so much better when you have your targeted replans and all of the nice features and OPA policies and everything just out of the box. But yeah, you have two ways and one more problem to solve with this beautiful thing, Terraform. Yes. over time, your infrastructure starts growing. You don't want to store your modules locally in one repository, but rather you want to reuse them across many repositories. And that's how you come up with your first remote modules. And the most natural way of doing that is referencing just a Git source. And using Git tags, you could have some sort of versioning. The problem is that this sort of versioning will not be a semantic versioning. You have to exactly specify the tag name, which is kind of suboptimal. And there is a solution for that called a registry, Terraform registry. It's an open protocol. If you have opted in for a tacos platform, I think almost all of them have a built-in registry. I think GitLab CI also has a built-in registry. But if you're, I don't know, GitHub Actions, you'll need to bring your own registry. There are plenty of open source solutions. You don't necessarily need to develop your own. We did that because it was a long time ago, like 5 years ago, we developed something called boring registry. It's really boring because it just pulls and pushes modules from S3. That's it. You can find it on GitHub. And honestly, this works. Registry, it works. There's no problem with it per se. The problem is that with this super simple, enthusiastic, nice thing called Terraform, you now have one more thing to take care of, to maintain, to keep up and running. Self-service, yeah. Over time, your organization becomes so big that your DevOps team cannot manage infrastructure on its own. And then you move to something called platform engineering. With platform engineering, the idea is that you provide all necessary tooling and resources and documentation and education for developers to be able to run their software and infrastructure by their own. And that will require you, obviously, a lot of work by itself. You will need to educate people. You will need to automate as much as possible to have really great reusable modules with sensible defaults so that it would be as easy as possible for developers to use it, and so on and so on and so on. And you would also really want to have automated everything around your infrastructure, the access management, creation of new, I don't know, repositories, pipelines, whatnot. And obviously, you would like to do that in Terraform, because you already started doing that on day 4, I think, with more providers. Now, let's say I don't have a problem with relationships between Terraform and platform engineering itself. Like, platform engineering is a problem on itself, and it's not Terraform specific. But I noticed this funny thing that when you're really deep into Terraform or OpenTofu, and you do platform engineering, your vendor buying decisions get impacted by the fact if there is a good Terraform provider for it or not. If you're selecting a new identity provider, and for example, it could be Okta versus something else, you would probably pick the one that has the most comprehensive Terraform provider so that you could really manage all the identities with it. And that I find kind of weird. That's why I mentioned it. Besides that, you will have a problem of, since you're offloading your tasks now to developers, the question is, where do you put infrastructure as code for the services? You could put it into service-specific repository, so you have a source code, and then you have Terraform code lying next to it. You could have a team-based structure following Conway's law, where you say everything that a team owns will be in this one repository, and all of this infrastructure going to be there. You could have a monorepo. Each of those approaches is valid by itself, and it all depends on your use case. I actually had a talk about that 2 years ago over here in Kuzminski University. You can find this one on YouTube and find out more about it. And the last but not least is the day 8. Over time, you're running your platform with self-service for developers, and you realize that developers don't really want to speak HCL. Of course, why should they? It is not even a real programming language. It has nothing to do with their day-to-day tasks. And then you're like, okay, if you don't like HCL, we have other solutions. How about JSON or YAML? The problem is that many developers are not good with YAML either. You'll have people complaining about indentation and the weird structures and whatnot. And it will also be a pain for you to parse and feed it into Terraform, to process it with weird nested for loops and whatnots. If you've been using Terraform long enough, you know that for loops can become very ugly very quickly. But yeah, and the take of this talk is this. I think that Terraform is great, but I also think that it can become very, very, very ugly. And I don't think that anyone who is right now not yet using Terraform but considers that should do that blindly. I think there are plenty of solutions, and some of them could be better fitted for you and your situation. For example, there is a CloudFormation that has automatic rollbacks, and it manages your the state for you. There are Kubernetes operator pattern where you manage your infrastructure as Kubernetes custom resources, such as in custom config connector for GCP or the Flux CD Terraform operator and many other solutions like that. You could also consider things like Pulumi or Terraform CDK or CloudFormation CDK, because, for example, it's much, much, much easier for developers to consume the modules written to consume them in the language they know and like, instead of learning a new language and a new syntax. And this is the Terraform story. Thank you.